Hello, superstars. All right, we're ready. We're going to go to Unit 9, Lesson 8. We're going to solve some log equations. This is the reason why we've been learning them. All right, so on the first couple here, they want us to convert this log equation into an equivalent exponential. And if you remember, log without anything written here is really log base 10. So it's pretty easy. You take 10 raised to the fourth. Remember, back to what power equals 10,000. And there's your equation. Okay, and this one here, the 10 underneath again, the base, 10 raised to the 1/2 equals square root of 10. That's your equation. So I want you to pause the video now and do the next few and then just check. So see, you should have gotten 2 raised to the 8th equals 256. Okay, and D, you should have 4 to the 4th equals 256. E, I forgot to tell you, there's a typo on that one. It should have been log of 1, so therefore 10 to the 1 equals 0. 10 to the 0 equals 1. And the last one here, F, 10 to the 3rd power equals x plus 2. So that's just remembering how to set those up as equations with exponents instead of logs. All right, so now we're actually going to solve these things. So this one, if you're doing what we just did, you're going to have 10 to the 0 equals 3x plus 7. So 10 to the 0 you know is 1, so 1 equals 3x plus 7. And now we're back to the old easy algebra stuff. Minus 7 from both sides. You get a negative 6 equals 3x. Divide by 3. And voila. X is equal to negative 2. And then just double check it. If I throw a negative 2 in here, what's 3 times negative 2? Well, it's a negative 6. Plus 7 is 1. And I can take the log of 1. We just can't be a log of 0 or below. Okay? And we're going to talk about that eventually in this unit. All right? Try number 2 and then check your answer. So pause the video and see what I got. And you should have got that x was equal to 11. And 11 does work if I plug it in. Plenty enough above 0. Okay, moving on to the next one. Now this one's a little bit harder. Do you remember the rule that goes when we're adding? You should remember that it's the same thing as multiplying. So I'm going to have the log of x plus 2 in parentheses times x plus 5. That's how I pull it out of the log. Remember, adding the same thing as multiplying, or when we go the other direction, we multiply. So equals 1. All right. Now what happens is basically they're taking the log of both sides. Actually, we're not taking the log of both sides. We're doing 10. Remember, base 10 right here. Raised to the 1 on the other side will equal the x plus 2 times x plus 5. So then we know that's 10. We have to do the old FOIL, or remember the box method. If you need questions in class. If you do the box method, you'll get x times x, which is x squared. And you'll get a 7x, and you will get a 10. Move the 10 over. So now I have basically x squared plus 7x equals 0. And just remember we got a factor. Well, what do? They have an x in common. So pull out an x. You're left with x plus 7 equals 0. And hopefully you remember t-split. So one answer is 0 and one answer is 7. If I put 0 back in up here, I do that, no problem. I'm still above 0, and I put 0 in, that works. And 7, of course, is going to make them bigger. So both are valid solutions. No problem. Now we're going to treat natural log the same way. Remember, another rule we had is if we got an exponent, it can come out in front. So this is really 5 times the natural log of 4x equaling 15. Then what I can do is divide both sides by 5. The natural log of 4x is equal to 3. Now, unlike log, when we have a written base, like back over here was a 10, this one is actually an e. So you're doing the e thing. So e to the 3rd power equals 4x. And then your last step to solve for x is just divide by 4. And so when I do that, the 4's cancel. and x is e to the third power divided by 4. So natural log has a little e underneath. Log there is base 10, and like I said, we'll talk about that in class as well. All right, I want you to pause the video, and I want you to try number 3 right here. So pause the video and let's see what you got. Okay, so just real quick, I moved the 2 to the other side here like that. Divided both sides by 2. Knew it was base 10, so I took 10 to the second power equals the 2x minus 2. Moved the 5 over here, divided by 2, and that's my answer, 95 divided by 2. Now, moving on to the next one. You should be able to do it too, but I'll go with you on that one. I'm going to move the 19 out in front. So 19 log base 2 of 5x plus 7. And I'm going to deal with this because you haven't really dealt with it except for base 10 so far. Next step will be to divide by 19. Get rid of that thing. So now I got log base 2 5x plus 7 is equal to 3. Then, just because it's not base 10, we can deal with it with log. So it's 2 to the third power. Take that with base of that equals 5x plus 7. 2 to the third power is 2 times 2 times 2, which is 8. 5x plus 7. Move your 7 over, move your 7 over. You're left with 1 equals 5x. Divide by 5, divide by 5. And x turns out to be 1/5. Okay? And if I check it back into the original answer right here, 1/5 of 5 is 1, plus 7 is 8. Plenty enough bigger than the number 0. Okay? So that's it. Let's move on to some more examples. Alright guys, so let's remember this. When we got subtraction right here, what do? So I got log of x plus 10, and you divide it by the x minus 1, and that all equals 2. So then you remember there's a base 10 here, so 10 to the second power equals x plus 10 over x minus 1. You can replace 10 squared with the 100. And if I put it over 1, I've got a proportion, so you can cross multiply. So you will have x plus 10 times 1, so that's x plus 10, equals the 100. I'm supposed to pick a different color. Take the 100 times the x minus 1, so that will give you 100x minus 100. So you got to distribute 100 on both. And then you just have to minus the x to one side, minus the x, and I would say add the 100 to the other side at the same time, so plus 100 over here. And you will basically get 110 equals 99x. Divide by 99, and that's the answer we're going to leave it at. So x equals 110 over 99. Now, 110 divided by 99 is a little bigger than 1, so if I add 1 onto 10, that's bigger than 0. And if I do 1 minus, a little over 1 minus 1, that's bigger than 0, so we are good. The answer is good. All right, pause the video. I want you to try this one right here, B, and then come on back and check your answer versus mine. All right, so on this one here, you guys had base 2. We're adding, so we got to multiply. So log those. And so 2 to the third power equals these two multiplied together. Change 2 to the third to 8. I moved the 1 over to this side. Took the square root of both sides. Remember, if you're taking the square root, you got to do plus or minus. So there are two answers. X equals 3 and negative 3. Now, 3 works. If I take 3 plus 1, that's bigger than that. Bigger than 0. And 3 minus 1 is bigger than 0. But negative 3, on the other hand, negative 3 plus 1 is not going to be bigger than 0. We cannot take the log of a negative, okay? And so this one is what we do is we reject it. And we actually call this is an extraneous solution. Okay? So really that's not a valid solution in our mind. It is a solution, but it's an extraneous one. We'll talk about that in class. So So x equals 3 is the only one here. That's why we've got to check them. That's why we're going to talk about that in class and come up with only the valid solutions. Alright, in this problem there's a couple ways of doing it. The easier way of doing it actually is to bring this log thing by adding it and bring it over to the other side. So then you're going to have the log of that whole thing, x squared plus 7x plus 12 equals the log of x plus 4. And we already have the log on both sides, so basically we can kind of ignore that part and just set them equal right away. So I've got an x squared plus 7x plus 12 equals x plus 4. Obviously the best thing to do is bring the x over. We got an x squared term's not going anywhere. Bring the 4 over by subtracting it. And you now have x squared plus 6x and minus 8 equals 0. Now we can go back and factor it. Now keep in mind there was more than one way of doing this. I got x and x when I'm factoring it. Factors of 8, it's going to be a minus 2 and a minus, let's see here, sorry, my bad. Alright, my error, it's a positive 8 there, so that's why I'm thinking this thing's wrong. It's x plus 2 and x plus 4. Let's get this right. There we go. They add up to 6 and subtract there. Okay, so add to 8. Multiply 8. Alright, getting late in the evening, we're creating a video here. So x will turn out to be a negative 2 here. X will turn out to be a negative 4 right there. Okay? Negative 2 will work. If I put negative 2 in here, that's still above 0. Negative 2 in here will become positive. That will also still be bigger than 0. But negative 4 makes that 0. So we will reject that one out. That's extraneous. Therefore, that's our only valid solution is x equals 2, negative 2. Moving on. Alright, due to timing on the video, I'm going to now have you pause them on each one, and I'm going to do them and come back and explain them real quick in a quicker synopsis, and then we can handle them in class. So pause the video, try the next two on your own, and check my work. Alright, so on these two here, hopefully you tried. Bottom line here, log base 2, you know you're adding, so you got to multiply the two together. We've got that. 2 to the 4th power here then equals, obviously 3x and that's 12x, divided by 12, and you got your answer. Nice and easy. 7, on the other hand, a lot more difficult. And in the natural log, first thing I did was take the 2, put it as the next one here. There's a lot of ways of doing this, so there's not just my way I'm showing you right now, many different ways. Subtracting the natural log of negative x. So then with subtraction, we do division. So I put this over this part right here. You got to remember you're doing the natural log, so you're going to take e of the 0 power over here equals this whole thing, which I did. Remember, e to the 0 power is equal to 1. Anything to the 0 power is 1, so I substitute that with a 1. When I cross multiply, 1 times negative x is negative x equals 1 times all this is the same stuff. Move the x to the other side, you got this equation. We factor it, and I get two answers, negative 4 and negative 1. Negative 4 will not work. That will give you a negative here. You can't take the natural log of a negative. Negative 4 would have worked here. Negative 1 will work here because negative 1 and to 2 is still above 0. The negative 1 is a positive 1, so that works. So the only valid solution you have is this one right here. This is valid. Okay, this is extraneous over here, so we reject that one. Okay, 2 more to try, same thing. Go on to the next 2, and you try them, and pause the video, and then I will give you the answers. Alright, due to time constraints here, just check these 2 out, and if you have questions, ask me in class about them, but I got it pretty straightforward how I did it and move things around. But by all means, we're going to practice this in